This is Mr. Precella picking up after our little break, and we're discussing trig identities, verifying trig identities, simplifying trig identities, and I'm about to do this problem. Let's see. Tangent x plus 1 times itself, so it's tangent x plus 1 all squared, minus secant squared x all over tangent x. Well, it's a multiple choice, but I won't bother showing all the choices right now. The way it's written right there, it's sort of trying to make sure you see the first thing you should do. There's really only one first step, and that would be FOIL this out. So if I FOIL that out, I'm doing that in this blue, I'd have tangent squared x, then a plus tangent x and another plus tangent x. That would be plus 2 tangent x and then plus 1 minus secant squared x all over tangent x. Well, one thing that's pops out right now is 1 plus tangent squared x is secant squared x. So if I add this and that together, tangent squared x plus 1, those two circle things give a pink secant squared x. We still have that blue plus 2 tangent x minus secant squared x all over tangent x. Well, secant squared x minus secant squared x, those subtract out. So we have 2 tangent x over tangent x. We can now cancel those tangent x's. So this one is 2. Wasn't that bad, was it? Okay, we're just working with more of these identities. So here it says complete the identities. What we've just proven is all of this equals 2. And here's our proof going through the steps. Now, number 19 is a little tricky. At first glance, you're going to think, oh, it's a Pythagorean identity. Well, no, there's no way you're going to get sine squared x minus cosine squared x. You can move the stuff around, but there's no way you're going to get sine squared x minus cosine squared x. And the same reason, the 1 minus cotangent squared x, there's no way you're going to get a positive 1 and a minus cotangent squared x by itself. So what to do? Well, if it's going to simplify this stuff here, a lot of stuff is going to have to cancel out. So here's what I'm going to do. I'm going to write everything in terms of sine and cosine, which really means I'm just going to replace cotangent squared x with cosine squared x over sine squared x. So here's the top. And it's sort of unfortunate that when you hear me or see me doing these, it looks like I'm just popping it out. But there is a thought going on here. And you're being new to all of this stuff. I'm not saying that you should be able to pop them out this fast. It takes some thought and so forth, but I just, on this video, I don't want to spend too much time just thinking and so forth. I deliberately don't look at the stuff before I start doing it. I print it out and that's it. But again, I have done these identities or simplified trig identities for quite a few years, longer than you have probably. So let's see. Once I have it like that, I'm going to get rid of this complex fraction by multiplying above and below by this red sine squared theta. Sine squared x, I mean. If I multiply above and below by sine squared x if I distribute this up here on top, I'm going to have a sine to the fourth x, which is sure getting that exponent bigger than I want it to be. So I'm going to wait and not distribute that yet. But down here in the bottom, I am distributing. So up on top, I have that sine squared x minus cosine squared x times sine squared x. That's just the top. All over. I'm about to do the distributing, and you're going to see that it just sort of falls out real quickly now. Sine squared x minus 1 is sine squared x. Then minus cosine squared x over sine squared x times sine squared x. When you do that multiplication, you would cross cancel the sine squared x. It's clear what I did just now to get this cosine squared x. Here's my invisible ink. Cosine squared x over sine squared x times sine squared x. So real light, just invisible orange ink. I have a twin brother that does this stuff also, teaching math here. And yesterday he was commenting to me, that orange ink does not show well and stuff. I told him, yeah, it's the invisible ink. You use that ink when you want to just show thoughts. This is how that canceled out. That's why we have cosine squared x. And you see now why I said, oh, it's going to work out real nicely. If you had distributed the sine squared, you'd have a sine to the fourth. What the heck are you going to do with that? Eventually, when you see what's down here, you might notice, oh, wait, that's not distributed. Because then that and that cancels, and you're left just with sine squared x. Okay. A very nice little proof there. Oh, now this one, whenever we have these two fractions with different denominators, we're probably going to wind up having to get a common denominator. And in this one, what would that common denominator be? Well, it's just going to be sine x cosine x. So we write this all with just one big denominator, sine x cosine x. Like on this one here, I need a cosine x down here. So if I multiply the bottom by cosine x, I need to multiply the top. And on this one, I need a, what do I need down there on the bottom? A sine x? See, there's already a cosine x, there needs to be a sine x. So if I multiplied above and below by sine x, this is going to be a little messy. I have to write real small. When I distribute this, I'd have sine x cosine x plus, is that going to be a cosine squared x? Cosine x times cosine x is cosine squared x. Now, we have a minus sine x that we're distributing through here. So I'm distributing the minus and the sine x. So that'd be a minus sine x cosine x. And then negative sine x times negative sine x. Is that going to be a positive sine squared x? Well, yes it is. On the bottom, we have the sine x cosine x now. And what's going to happen with the top? I think it's going to simplify pretty nicely. Sine x cosine x minus sine x cosine x, that subtracts out. And then also, we have a sine squared x plus cosine squared x. Right here, I'm going to circle in green the cosine squared x plus sine squared x. What can we replace that with? Well, you could replace that with a 1, couldn't you? And then if we think of this as 1 times 1, 1 over sine x would be cosecant x, 1 over cosine x, secant x, and the way it's written is secant x times cosecant x. Okay, that's the same thing as cosecant x times secant x. Now follow that? See what I did? Any questions? It's a little messy. But we're subtracting fractions. Number 21. Says complete the identity. Okay. Well, if it's going to simplify to one of these four, it's either 0 or cosine x. Now, if it's tangent x, more than likely we're going to get sine x over cosine x. And if it's cotangent x, more than likely we're going to get cosine x over sine x. So it's a matter of looking and trying to figure out where the heck do you start. Well, my thoughts are, if this is going to simplify to one of these, somehow or another we're going to probably need to cancel that denominator. Well, to cancel 1 plus cosine x, that means we need something up here that has a 1 plus cosine x so we can cancel it out. So I'm going to target this sine squared x. I have the black 1 minus, and then a fraction bar, 1 plus cosine x is down there. So sine squared x, if I'm thinking, okay, what has 1s and cosines and a sine squared? Well, that would be this first Pythagorean identity. Have y'all gotten good at moving the stuff around? You can subtract cosine squared x, and you just have sine squared x equals 1 minus cosine squared x. And sometimes students will cancel wrong and still get the right answer. They might cancel the 1 and cancel a cosine. Well, really, no, you've got to factor before you can get that. This is one of those where even if you factor wrong, you might still wind up with the right answer. Or cancel wrong. That 1 minus cosine squared x, you should factor that as a difference of squares. A squared minus b squared. A minus b times a plus b. This is 1 minus cosine x times 1 plus cosine x. And now I can cancel the 1 plus cosine x. So I have 1, that black minus, and 1 minus cosine x. Oh wow, this works out really nice. When you distribute that minus, we have the black 1, then a minus 1, and what? A plus cosine x. Just cosine x. Your homework problems will be similar to these examples I'm doing here. Number 22. Oh, heck. Here, on this one, there's something you can do on this fraction that you can't do like up here. You can only do it if there's just one term in the denominator. If there's just one term in the denominator, one thing you can do is separate it. Write it as 1 over sine x minus cosine x over sine x. And 1 over sine x, that is 1 over sine is cosecant. So cosecant x minus what? Cosine over sine is cotangent x. Just showing you techniques for simplifying trig identities. This is different. This whole course is different from college algebra, where you do the quadratic formula and then, okay, here's a dozen problems doing the quadratic formula. All they're doing is changing the numbers and stuff. It's that same repetitive pattern. Here, not every problem is different, but they're sure not exactly just repetitive. But every now and then you run across problems. Okay, once you know how to, once you look at it, like at 21 and 23, maybe we could do on 23 what we did on 21. See, we have that 1 plus sine x down here in the bottom. So I'm going to go about it this way. Well, let me see if I can. I'm going to write down the black 1 minus, and then the cosine squared x, let's write that as, let me write my black fraction bar. That cosine squared x would be 1 minus sine squared x. Then you could do a little incorrect canceling if you don't factor it first. And factor 1 minus sine squared x as a difference of squares. 1 minus sine x times 1 plus sine x all over 1 plus sine x. So 1 plus sine x cancels. Go ahead and distribute the 1. So we have that black 1, then a minus 1, and a plus sine x, which simplifies down to what? Just a sine x. Any questions there? Now, let's see this next one. At this point, we're about wrapping it up. We're almost through. What can we do? Well, if in doubt at this point, when you look at something and you're unsure, especially if the trig functions aren't sine and cosine, maybe what you want to do is write it in terms of sine and cosine. That cotangent x we could write as cosine x over sine x. And then inside the parentheses, tangent is sine x over cosine x minus secant is 1 over cosine x. Now distribute this. And have y'all gotten pretty good at multiplying a function and its reciprocal? The cosine x's would cancel, cross cancel, and the sine x's. So when you start distributing, the first thing you're getting here is a 1, then minus, let's distribute there. Here the cosine x's would cancel, so you'd have 1 over sine x remaining. Do y'all follow that? The cosine x cancels, so you have 1 over sine x. So what do you think we're going to put in place, or is our answer. We're not going to write 1 minus 1 over sine x. What would it be? It would be a 1 minus, what do y'all think I'm going to put in place of the 1 over sine x? Cosecant x. This was one that's not a multiple choice. Okay? Y'all following what I did there? Oh, wow. This is the last one I have as an example to work out. Okay. This is trying to see. I hope this is focused good. Well, what do y'all think we're going to do here first? First of all, I have an idea. I have a feeling that this first Pythagorean identity is going to come into play somewhere. But the first thing we should do is expand that 1 plus sine t squared. Could y'all FOIL that out? I'm sure some of you can do this expanding in your head. It'd just be a 1 plus sine t plus sine t would be 2 sine t plus sine t times sine t would be sine squared t plus, we still have this plus cosine squared t. Oh, this, for the last one I have here as an example, it's not a bad one. The sine squared t plus cosine squared t would give us a 1. And then you can add the 1s. 1 plus 1 is 2. And then we still have the plus 2 sine t. Don't get carried away and add those 2's. You can't add them because those aren't like terms. There's not a sine t on this first 2. So just write 2 plus 2 sine t. Or if you want 2 sine t plus 2, that's fine also. Okay? So that's all I wanted to say about our, here in this video, just doing more of these identities, like simplifying identities, verifying them, and so forth. And so nothing replaces working on these things. You've got to work on them and try them yourself. So if you haven't started the homework yet over these trig identities, especially if you're in the online class and you're listening to this, it's tempting just to delay, but don't. Start it now. Okay? So we'll be discussing some new identities, not new, we'll add some more identities that you need to learn, something called the sum and difference identities the next time. It's 6 new identities for you, but not really, and they're pretty easy to memorize, okay? So we'll be discussing that the next time. So as I'm recording this, it's the day before Thanksgiving, so happy Thanksgiving. If when you're hearing it, it probably won't be Thanksgiving, but okay. Anyway, I hope you had a good Thanksgiving 2014. Thank you.